Hello guys, today I'll be explaining the limit of function, particularly the direct substitution of limits using just three examples. I'm not going to waste your time. So this is one of the examples. Now, there's a quiz, or if you watch this particular video to a particular extent, you see the quiz question that I want you to try. So let's jump right into it. So this particular question says we should evaluate the limit 3x squared minus 1 of 4 minus 2x squared at the denominator. So we're just substituting direct here. So the value of x approaches what? 1 over 2. So I just have my 3 here, open bracket. I have my 1 over 2 substituted in that value of x there, in that x there, sorry. And we have the denominator as what? 4 minus, we have 2 open brackets, also 1 over 2 because there's an x here with a square. So that is that. Now, if you square half, you square 1 over 2, you get to 1 over 4. So this is 1 all over 4. And all divided by, we have 4 minus 2 open brackets, 1 over 4. Beautiful. So if we um, open this particular bracket at the numerator, we have 3 over 4 minus 1. So I'm going to write it as 1 over 1 at the numerator here. And the denominator is 4 over 1 minus 4 minus 4 over 1 minus 1 over 2. All right, so this now, the LCM at the top there is what? 4, right? So we have um, 4 multiplied by 4 divided by 1 is 4 multiplied by 1 gives us this. So I'm going to um, wrap up the numerator. Let's finish up with the numerator first. So we have minus 1 all over 4 as the numerator. And for the denominator, we now have the LCM. The LCM for now the LCM for the denominator is what? Is 2. So 2. Now 2 divided by 1 gives us 2, multiplied by 4 gives us 8. So we have that. And this is equal to what? 7 all over 2. Now I'll rule a line here so as we get that straight. So now the limit, finally the limit of what? Of 3x squared minus 1 all divided by 4 minus what? 2x squared is now equal to the the now is equal to the numerator is minus 1 over what? 4. Now I'm going to write division sign here for the division sign. The denominator is 7 over 2, right? So if we flip the second fraction, we're going to get what? 1 over 4 multiplied by what? 2 over 7. Recall this from rules of what? Fraction, of divisions of what? Fraction. So this now becomes what? 2 can go into 4, right? 2 here, 2 divided by 2 here, 1, and 4 here, 2, right? So we have minus 1 all over 2 times 7 is what? 14. So the final answer to this particular question is what? Minus 1 over 14. So if you have a question, if you if you have a comment to this particular explanation, you can drop it in the comment section. Thank you as we move to the next question. Now, this the second question here is also simple direct substitution of what? Limit. All right. So at the numerator we have 1 plus what? 1 plus 9x minus what? 2. And the denominator we have what? 3x minus what? X squared. So this is equal to, we have 1 plus. So let's substitute directly. What do we have? We have 9 here, open bracket, 3. There's a minus there, minus 3. and raised to the power of minus 2, all divided by, we have 3 open bracket minus 3 because there's an x there, minus open bracket minus 3 square. So this is now equal to, so we have 1 plus 9 open bracket. Now this is the same thing as um recall that when you have a to the power of 2 is the same thing as 1 over a squared. Alright. So a to the power of 2 is the same thing as 1 over a squared. So this becomes what? 1 all over 9. 3 squared gives us what? 9. Divided by. Now, the denominator 3 times minus 3 gives us minus 9 minus 3 square minus 3 square gives us what? Positive 9. So we have that. So let me bring everything down here now. We have 1 plus. Now, 9 times 1 at this part. 9 times 1 is 9. 9 divided by 9. 9 divided by 9 is what? 1. So this now becomes what? The denominator is just 9 minus what? 9. Which is the same thing as what? The numerator is now what? 2. And the denominator is what? Minus 18. And if you reduce this further, it becomes what? 1 all over 1 all over what? Minus 9. So this is the answer to this particular question. Beautiful. Third question. Now, if you look at this particular question, the third question here, we have the tan inverse of x squared minus 1 divided by 2 open bracket x minus 1. Now, because we have an x squared minus 1, right, it shows that the expression inside there is a difference of 2 squares. Recall that the difference of 2 squares that I did in the previous video, it's something like this: x squared minus 1 and x plus 1. Please, if you've not watched the video, right, I will drop the link. There's a link in this particular video there for that one that you can just click and it will take you there to see what I'm talking about. All right, so let's fix what we have here as the difference of 2 squares in the expression or in the limit. So we have the limit x approaches what? 1 of the tan inverse of what? Difference of 2 squares now. X minus 1, x plus 1, all divided by 2 open bracket x minus 1 close bracket. Now, because the denominator we have x minus 1 and the numerator we also have x minus 1, just we strike this one out. And this is now equal to what? The limit as x approaches what? 1 of what? Tan inverse of what? X plus 1, all divided by what? 2. Recall there's a 2 down there. All right? Beautiful. Now, let's fix our limit. So this now becomes the tan inverse of, now, x there is 1, so we have 1 divided by 2. Now, 1 plus 1 is what? 1 plus 1 is 2. So this is tan inverse of what? 2 divided by 2. And 2 divided by 2 is what? 1. So tan inverse of what? 1 is equal to pi radians or 45 degree as an angle. So this is our answer. Now, I want to introduce the idea of L'Hopital's rule to you, right? Which is one of the most simplest form of solving limits that are indeterminate, right? The limit that you know you cannot determine the final result, because if you substitute, you're going to get directly 0. Now, if you look at this particular limit here, right? This one we just solved. If I fix the value of 1 here in this particular expression, right, I am going to get a 0 direct. If I fix 1 here, 1 square is 1, 1 minus 1 is 0. Now, Down at the numerator here, 1 minus 1 is what? Also 0. So everything is going to give me what? 0. So it is indeterminate. So whenever you have an indeterminate limit, right, you use the idea of what? The L'Hopital, right? Use the idea of La. What I mean is you have a limit of function, say this, of f of x, and the answer is what? 0 over 0. This is what? An indeterminate function, right? So all you need to do is what? You use the idea of what? The L'Hopital.